Today we're doing lesson 14.2, cube roots. For our key idea, when you multiply a number by itself twice, that's called cubing the number. They give you an example there. Symbol for cubing is the exponent 3. 4 times 4 times 4 is 64. So 4 cubed is 64. And to undo this, or the inverse of this, you have to take the cubed root. So that's that radical symbol that we looked at in our last lesson, but there's a little 3 in there to indicate that you're actually taking the cubed root. So the cubed root is 64. So our definition here, cube root of a number is a number that, when multiplied by itself and then multiplied by itself again, equals a given number. A perfect cube is a number that can be written as the cube of an integer. The symbol, the little check mark with a 3, that's a radical sign with a 3, is used to represent the cube root. So here's a table for some of our perfect cubes and the cube root. So notice how you can have a positive perfect cube, or you could have a negative perfect cubed. However, for cubes, unlike squares, it can't be both. It has to be either one. You can't have two options. So perfect cube, I've got 1. 1 times 1 times 1 is 1. So the cube root of 1 is 1. Perfect cube is 8. You have to do 2 times 2 times 2 to get to 8. 2 cubed is 8. So the cube root of 8 is 2, and so on. So here's just some of the common perfect cubes that will be seen in our lesson for today. All right, so for our first type of problem, we are finding the cubed root. Again, unlike the square root where we sometimes have 2 answers, for a cube root, there's only going to be 1. All right, so cube root of 8 is 2. That's because 2 times 2 times 2 is 8. Here, the cube root of negative 27, there's a negative here, which means my answer has to be negative. Negative 3 times negative 3 is positive 9. And then positive 9 times a negative 23 is going to give us negative 27. You cannot have a square root with a negative on the inside there. You can have a negative on the inside of a cube root. Okay, and then our last one down here, at the bottom you have a fraction 1 with a cube root that works just the same way as the square root does. If you can simplify it with division here, you certainly can do that. Otherwise, if you have perfect cubes on both parts, then you can just do the cube root of both parts. So the cube root of 1 is 1, the cube root of 64 is 4. All right, so evaluating the expression, we did problems like this in our last lesson. Order of operations, the radical symbol still works like a grouping symbol, so we do it in the parentheses step. And then we evaluate or get rid of that cubed root during our exponents and step. That's in that same step. And then we do all the rest of the order of operations for whatever else is there. For A, I have 2 times the cubed root of negative 216. This 2 in front of the exponent, or the 2 in front of the radical symbol, is like multiplication. It's just like a 2 in front of parentheses. So it's just a different way of writing multiplication. Okay, so parentheses. Don't have parentheses, don't have any operations within my problem. So next I'm going to go ahead and evaluate. The cube root of negative 216 is negative 6. Now I'm going to do 2 times negative 6. That gives me the answer of negative 12. For B, let me erase here so you can see. That has the cubed root of 125 to the 3rd power. I had them crossed out there because they do cancel each other out. Although you certainly don't have to solve it that way. You could do the cube root of 125 is 5, and then 5 to the 3rd power is 125. But if you realize that that exponent and that radical symbol cancel each other out, it makes the problem a lot faster to solve. Okay, go ahead and pause the video and try these next 4 problems. Okay, let's check our answers. All right, number 1, the cube root of negative 343 is negative 7. For 2, cube root of 27 is 3. Cube root of 1000 is 10. We have a negative sign here, so we have a negative sign in our answer. All right, for number 3, We do the cubed root of 8 first, which is 2. Then after we do that, we have to do multiplication as our next step. 4 times 2 is 8. Or you could have done boom, boom, made it plus -4, -4, then we have -8. 18 minus 8, 10. All right, and then on number 4, I chose to just cancel out the cubed root and the cubed, because I know they're inverses. They cancel out. It leaves me with the problem -64 plus +43, and that equals -21. All right, so let's take a look at this one. This is an evaluation problem, which we haven't seen these in a long time, but we have done evaluation problems this year where they give you the number to put in for the letter, and then you need to simplify the expression. So evaluate x divided by 4 plus plus the cubed root of x divided by 3 when x is 192. So the first thing we do is we write our order of operations problem with the number 192 instead of x. So 192 over 4, 192 over 3. Okay, 192 is not a perfect cube. It's not something that I would expect you to know off the top of your head. It's certainly something like this where you go back and look at what your perfect cubes are might be helpful. And 192 is somewhere in between 5 and 6 in value, but it's not on there. So we're going to go ahead and just do that division. Let me go back to where we were. 192 does divide evenly by 3. It gives us 64, which is a perfect cube. So we did our parentheses, or grouping symbol. We did our exponents, radical signs. So the cube root of 64 is 4. Okay, this looks like a fraction, but remember, fraction is the same thing as division. So we're just going to do 192 divided by 4. That gives us 48. So we're basically changing that improper fraction into a whole number. And then we are adding. So 48 plus 4 equals 52. We're still using the same order of operation steps that we did at the very beginning of the year. Parentheses, exponents, division, addition. Okay, so here are 2 problems to try. Go ahead and pause the video and try them both. Okay, let's check our answer. All right, so for the first one, you had to substitute 64 for the letter y. So here 8y means 8 times the value of y, which is 64. So you have to do 8 times 64, that's 512. So we have, and then plus y, so there's our other 64. This part is not in the parentheses, the plus y here, that's separate. So within the parentheses, we do the multiplication, we do our cubed root. Cube root of 512 is 8, plus 64 is 72. All right, on this next one, we have 2 times b minus the cube root of 9 times b, where b equals -3. So again, we're going to take in that -3, we put it in for b. So 2 times -3 minus the cube root of 9 times -3. Again, that cube root symbol acts like parentheses. Whatever is in there, we have to do first. So 9 times -3 is -27 is our first step. Exponents and radicals come next. So cube root of -27 is -3. So now we have 2 times -3 minus -3. 2 times -3 multiplication is our next step. That's going to give us -6. Minus a negative, I did boom, boom, made that plus positive. -6 plus +3 is -3. All right, let's take a look at our story problem here. Find the surface area of the baseball display case. And we know it is a cube because the picture shows us all the sides are the same length. And we know the volume is 125 cubic inches. So the first thing I need to do is figure out how long the side length is. And to do that, I have to do the cube root. So the cube root of 125 is 5 inches. That means each of these sides is 5. So then you have to think back to chapter 9 where we did surface area. To find the area of one side, it's a square. You have to do length times width. For this one, that means 5 times 5. And then there are 6 equal sides on a cube. So we take that times 6 because there are 6 sides that each have that 5 times 5 part of area. So when we multiply it all out, we get 150 inches squared. All right, so our last one here, explain the difference between the square root of 64 and the cubed root of 64. Go ahead and pause the video and try that problem. Okay, let's check our answer. Square root of 64 is 8. The cubed root of 64 is 4. That's because for square root, it only has to be multiplied by itself twice, 8 times 8. But on the cubed root, it has to be multiplied by itself 3 times. 4 times 4 is 16 times another 4 is 64.